Hello everyone, my name is Rishabh Sirswa. I am from Jhunjhunu, Rajasthan. I have completed my schooling from my village and from RBSC board. And I have completed my graduation from Shekhawat University, which is a state university of my state. And now I am proceeding my post-graduation from IIT Ropar. Today I am going to teach you the thermal expansion, which is a subtopic of heat. So now, what is thermal expansion? When we increase the temperature of a body, the body will expand or the dimension of body will expand. So now, what is the uses of thermal expansion in our daily life? So you uses thermometer. In thermometer we have mercury. So when the thermometer touches your body, the temperature of mercury changes and the mercury will expand. Or you see the railway tracks. There is a gap between railway tracks to allow the thermal expansion. If there is no gap between railway tracks in winters or in summers, there is a deformation in the railway tracks or the railway tracks will deform. So to prevent this, there is a gap between the railway tracks. So we will see what is the thermal expansion and how these concepts daily we use in our daily life or how this will come in our exam life. So thermal expansion is a subtopic of a heat. So when you increase the temperature of a body, the body will expand. This is the main concept of thermal expansion. So what is the reason behind it? So when you increase the temperature of body, the separation between the atoms which is present in the body will also increase. So the dimension of body will increase or the so now we will see what is the physics behind it. Some people say there is a amplitude or there is a frequency changes. So no, there is a separation between the atom which is changes when you increase the temperature. The answer of the thermal expansion comes out in atomic physics. So in atomic physics we have potential energy. Uh, we have potential energy and we have X, which is separation between the atoms. Separation between the atoms. So now, if we have like L1 body with X naught is its midpoint. Now, if we changes its temperature, so now like we have this is even energy. This is the potential energy of this rod with temperature T1. Let's say the temperature of body is T1. So E1 is correspond to T1 temperature's body. T1 temperature. So now if we increase the temperature of a body, so what will happen? So now here the potential energy of the body will changes. It's come out to be T2. It's correspond to T2 temperature. Here T2 is greater than T1. So now what is it? Here you see there is two points. Like here we have X naught, so here X1 and X2. Okay, X1 and X2. So you will carefully see when you increase the temperature of a body, its mean point. Suppose it's like here X0. So when you increase the temperature of a body, its mean point will shift because this length is greater than this length. So the mean point or the mean separation of the body will shift. So this comes out to be here, and in next it comes out to be here. So the mean point of energy changes, which means the length of body increases. So this is the main concept behind the thermal expansion. So now we will see the mathematics behind the thermal expansion. So now let assume we have rod L1 with temperature T1. Okay. Now we increases the temperature of a body. Here our temperature is T2. Let's say the length of the body or the length of the rod increases to L2. Okay. So now the change is length, which is delta L is equals to L2 minus L1. This is the change in length. We have seen when we increase the temperature, the length of the rod is changing. So the change let's say this is our length which is changes delta L. So delta L. So on which physical quantities the delta L is depend. So the delta L is depend upon change in temperature, or the delta L will also depends upon initial length L1. Okay. So when you combine these, you come out to delta L proportional to change in temperature or the initial length of the body. If you vary the proportionality sign, you come out to be alpha. Here this is the proportionality sign, and this is alpha is a coefficient, delta L, delta T, or L1. So alpha is the linear thermal coefficient. So now this is the main point, that we have take a rod, a 1D material. So this is a rod. So we have taken alpha is a linear thermal expansion coefficient. We have taking our discussion. We are taking our discussion to a linear body, not a 2D body or 1D body. So this is delta N is equal to alpha, delta T, and L1. So now delta L delta L is equal to L2 minus L1 equals to alpha delta T L1. So L2 is equal to L1 plus alpha delta T L1. So I am taking common L1. So L1 1 plus alpha delta T. So this is the main formula of linear thermal expansion. For alpha here, alpha is linear thermal expansion coefficient. So this is the main mathematics behind the thermal expansion. So now we will see an example of thermal expansion. Till now we have completed the concept of thermal expansion. Now we will see an example. So we have an example that if we have a rod with linear thermal expansion coefficient with 2 into 10 to the power minus 4 per degree centigrade. Now if we changes the temperature of a rod from 15 degree to 35 degree. So if the initial length of a rod is 1 meter, find the new length. So in this example, we have given that we have a length of 1 meter. Now we changes the temperature of a body from 15 degree to 35 degree. So if the initial length of a body is 1 meter, so we have to find the new length after the temperature changes. So here we have the formula L2 is equal to L1 1 plus alpha delta T. So delta T is change in temperature. So delta T is equal to T2 minus T1. Now T2 is the new temperature, T1 is the initial temperature. So the new temperature is 35 degree, and the first one, the initial temperature is 15 degree. So we come out with 20 degree. This is the delta T. And alpha we have given, and L1 is 1 meter, and alpha is given 2 into 10 to the power minus 4 per degree. So now simply we will put these information to our formula, and we will get the result. So now L2 is equals to L1 is 1 meter, 1 plus alpha is 2 into 10 to the power 4, and delta T is 20. So now when you simplify it, you come out with 1.004 meter. So now this is the new length of our body, 1.004 meter. So our initial length, as you can see here, is 1 meter. So if we change the temperature, it come out to be 1.004 meter. So till now we see how the temperature changes of a linear body. Like we take an example of a rod. So what happens when we take a cube, 2D body? This we will see if we meet again in our classes. Thank you.